Hello everyone, welcome to Algebra 2 Notes. We're going to be going over notes through a video like this, so it just makes it a little bit easier for you guys to follow along. For the first one here, we're looking at Chapter 1, Section 1, Expressions and Formulas. All of Chapter 1 notes, really everything that you do in Chapter 1 for Algebra 2, is a review of what you've learned in Algebra 1. Super condensed, really straightforward, to the point, but very critical for you to succeed in Algebra 2. Really important for you to remember everything. So we'll jump right into it. First is going to be order of operations, PEMDAS. Many of you remember this. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. All right, we'll jump straight into it, just practicing what, again, we should have learned in Algebra 1. But if any of this is news to you, please bring it up in class. We're here to help you. This is why we do a review, to get you a good foundation for Algebra 2 going into it. So the first thing we look at for expressions like this are parentheses. We do have two sets. We've got some brackets here, and we've got much smaller ones here. So when you're working within brackets, you want to go as far out as you can first. So first, we're looking at these set of red brackets here, and then we're looking at these smaller ones here. We want to work inside out. So get rid of all these for now. We're going to work on what's initially inside this right here. Everything is already solved for everything within this parentheses. So really, what we need to do is just multiply that by the number out front, this 9 right here. So we can rewrite this if we want to just get rid of parentheses as we go. 5 plus 9 times 4. And that's going to mean exactly what it shows up top. Now that we don't have the parentheses down here on the bottom, we can start doing some multiplication. And I find that when I'm reviewing this type of work, I like to have a little cheat sheet right next to me. So PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Within this set of parentheses, these brackets that we have here, we don't have any more parentheses. We just handled that. So we are set. We don't have any exponents, so we can move on down to multiplication. We do have multiplication though, so let's start working on that. We'll bring everything else down. 5 plus 9 times 4 is going to give us 36. Bring that bracket down. So we've solved all of the multiplication. We have no division. Addition is what's coming next. Again, we're just focusing within this bracket. So we're going to go 10 minus what's left in this bracket is going to be 41. And now that we're just left with a single value within those brackets, we can pretty much get rid of it as long as we remember what's happening to it. We're subtracting everything within this bracket. But that's pretty straightforward as well. 10 minus 41 is going to give us negative 31. And we're all set. Now, if you were to do all of this in your head, that's great. And you write negative 31, that's great. On a test, when we're looking for PEMDAS and order of operations, if you write down just equals 31 and you got rid of everything here, and that's all we saw, that would be wrong. That's not what we're looking for. We're looking for all of these steps. If you want to make it very clear that you got the right answer and write that up there, that's fine. But we need to see these steps. That's what we're looking for. Let's move straight on to the next one here. All right, let's see. We've got PEMDAS. Let's see. We have parentheses in this whole expression. Yes, we do. So we're going to look at this set right here first. Do everything within these parentheses. All we've got is 4 minus 2. Easy enough. So 4 minus 2, which is going to be 2. Bring everything else down. 2 plus 2. There's an exponent up here. 3 plus 6. All the parentheses are gone. We do have an exponent, That's what we're looking for here. So 2 raised to the third. If we forget what exponents actually do, 2 to the third is the same thing as 2 times 2 times 2. That's 1, 2, 3 of them. If we had 2 to the 5, we need to add on 2 more 2's. That's 4 and 5. But we're just looking at 3, so we can get rid of those. Write this as a 3, and if writing it out like this helps, by all means, write it out. So we've got 2 times 2, that's 4 times 2, and that's going to give us 8. We can bring everything down. 2 plus what we now know is 8 plus 6, and then it's just addition because we've done all the exponents. There's no multiplication or division, and now we're on we're on addition. 2 plus 8 is 10 plus 6. 10 plus 6 is 16. Great. And again, this is what we're looking for. We're not looking for just an equals 16. We're looking for all of this work. 2 more of these order of operations, and we will be set. All right. This one has 2 sets of parentheses again. We've got a small set and a slightly larger set. So again, we're going to work from the inside out. So first we're looking at that 7 minus 2, this set of parentheses right here. That's going to give us 5. Let's raise to the third, and there's a 3 out front. Let's bring everything else down now. 384 minus, there's a bracket here, divided by 3. Now, this parentheses we've essentially dealt with. This one right here in the middle. So again, as long as we understand what's happening to that value within the parentheses, it's being raised to the third power right here, and it's being multiplied by 3 right here. Now this is where sometimes folks will mess up. They'll see this 3 times 5 and go, oh, easy, 15. Raise that to the third. That is going to give us the wrong answer because we need to follow order of operations. So we've already done this one parentheses, kind of. We still have another set of parentheses here, but as far as everything within this bracket, there's no more parentheses. So now we can start dealing with exponents. Are there exponents? Yes, there are. 5 to the third. And again, that's 5 times 5 times 5. If we look up here. And 5 times 5, that's going to give us 25 times 5. 25 times 5 is going to be 125. So we can write that in as 384 minus 3 times 125, the brackets there, divided by 3. Now, within this set of brackets, all the exponents are dealt with. Now we can do some multiplication. Let's see. We can do 3 times 125. That's going to be 375. 384 over here. And again, that was minus, divided by 3. I'm going to bring everything up here to make it a little bit clearer, easier to see. Let's see, within this bracket, no more multiplication or division, no addition either. We just have subtraction. 384 minus 375 is going to be 9 divided by 3. It's going to give us, I don't know what I was trying to write there. That's going to give us 3. One more, and we're all set. For fractions like this, you need to remember that numerators and denominators are their own independent values. So we can pretend there are brackets around the denominator and the numerator of fractions. And we can deal with each of these as their own equation until we're down to one single value. So let's deal with this top one first. We're looking at 16 plus 2 to the third divided by 4. If we scroll up a little bit, we'll see my previous cheat sheet. Perfect, right here. So parentheses, that's what we're dealing with right now. So we've already found ourselves within parentheses. Exponents, we actually have one on the top and the bottom. Perfect. So 16 plus 2 to the third. 2 to the third is going to change into, let's see, 2 times 2 is 4 times 2 is 8, plus 8 divided by 4 all over 1 minus 2 squared is just going to give us 4. And remember, the reason that we're dealing with these independently is because they're within parentheses by themselves. So the next step for us is going to be 16 plus 8 divided by 4. We don't have any more exponents. We don't have any multiplication. We do have division here on the top. So that's going to be 16 plus 8 divided by 4. 8 divided by 4 is 2, and that's over. There's no multiplication or division there. So 1 minus 4. Again, keep these in parentheses. It'll make it a little bit easier to follow exactly where we were going before. So 16 plus 2 is going to be 18. 1 minus 4 is going to be negative 3. And 18 over negative 3 is going to give us negative 6. Remember, if there's two negatives, if it was negative 18 over negative 3, that would give us positive 6. If it was negative 18 over 3, that would give us negative 6. But if there are two negatives, that's going to give us a positive. That's not the case here. We're dealing with 18 over negative 3, so that's going to give us a negative number, in this case, negative 6. All right, a few notes here. Blank are symbols, usually letters, used to represent unknown quantities. There are some symbols that we can use in algebra. The most easily identifiable one here would be pi. So they're not always letters. They can be symbols to represent a very specific number. But in most cases, in algebraic expressions especially, we're looking for variables. Variables are symbols, usually letters, used to represent unknown quantities. Algebraic expressions are expressions that contain at least one variable. And when you're finding a specific variable and plugging it into a formula like this, pan over a little bit here, I always recommend putting them within parentheses. It won't make that much different here for this first one, number 2 that we're going to do, but once we start dealing with variables that have negative values, like z here equals negative 1 and y here equals negative 2, it's very important that we keep them as one number that is being multiplied or raised to a certain power, and you'll see why here in a little while. But first off, this first one, just to get us warmed up here, let's substitute these s's with 5s and these t's with 2s. So we have 5 minus t, which is 2 times the quantity s squared. I said s even though it was a 5. Let's see, 5 squared minus t is 2. And that's it. We've done all the substitution we need. So let's deal with this first, this parenthesis here. Within this parenthesis, we do have an exponent. So that's 5 squared is 25 minus 2. We'll keep that in a parenthesis there. Bring everything else down. 25 minus 2, that would be the next step here. We have 5 minus 2 times the quantity 23. And now that we have a single variable in here, we can get rid of the parentheses as long as we know what was happening to it. It was being multiplied. So next is multiplication. 2 times 23 is going to give us 46. And then 5 minus 46 is going to give us negative 41. And that's it. Pan on down a little bit. This one will take a little bit longer, but not too much. Let's see. Again, for this, I always recommend putting in some parentheses so you remember to deal with this top number independently and this bottom number independently, because really all these symbols and numbers are just representing individual values. Even though there's a lot going on here, negative 8x, y minus z to the third, really that's just going to equal some number. Even though there's a lot of variables going on, it's just a single number. So treat it as such, just one number. So let's rewrite it down here. Negative 8 times x, which is 5, times y, which is negative 2, minus z, which is negative 1 to the third power, all over y squared. So y is negative 2 squared plus 5. And here's why it's really important to make sure that you're including those parentheses when you're substituting these variables with the actual numbers. If we were to see this, we would go, oh, let's see, that's -4 plus 5, and that's going to give us 1. That's not what we're actually doing. What we're squaring here on this bottom portion is -2. So -2 times -2 is going to give us a positive. And we'll see more of that as we go through this question here. So on this top portion, this huge bracket up here, are there any exponents? Yes, there are. The -1 times -1 times -1. Well, no, two negatives equal a positive. So that's just going to give us 1 times -1. 1 times -1 is -1. Perfect. So we'll write in everything else. -8, 5 times -2 minus -1. And here on the bottom, we also have an exponent, -2 squared. -2 times -2 is going to give us 4 plus 5. Excellent. Now here up on the top, we've dealt with the parentheses that matter. And no more exponents remain, so we can jump straight over to multiplication. There's plenty of that. Now, how I would attack this one is multiply the 5 by the 2 first. The order in which you multiply these numbers does not matter. The reason I would multiply the 5 and the -2 is because that would give me -10, and it's just easier to multiply any number, really, by 10. You just tack on a 0 at the end or move a decimal point. But for the sake of this, we'll attack it left to right. So we're looking at -8 times 5. That's going to give us -40 times -2 minus -1, all over 4 plus 5. This next step here, we still have some multiplication to do. Negative times a negative, again, that -2 and that -4 are going to give us a positive. So we're looking at really just 40 times 2. That's going to give us 80 minus -1 over 4 plus 5. Now, if we subtract a negative, that's the same thing as adding. So we're going to get 81 over 9. 81 over 9 is 9. And we are all set. We've got one more problem and one more piece of vocab, and we'll wrap it all up. A blank is a mathematical sentence that expresses a relationship between two certain quantities. What we're looking for here is formula. Formulas can be very complex or they can be very simple. For instance, the area of a square is just the length of its side squared. For something a little bit more complex like a trapezoid, we're looking for the 1/2 height times B1 and B2, base 1, base 2. That can be length. It's typically how it's described. So let's read the whole question. Find the area of a trapezoid, and that's what we have right here, with lengths of 13 meters and 25 meters and a height of 8 meters. So they're all meters, so we won't have to deal with any weird conversions. That makes it very easy for us. And now we just need to plug it in. So if we have an H here, that stands for height. In most formulas, when you see an H, that means height. So H is going to equal 8 in this case. B1 and B2 are just the lengths of this trapezoid. So we have B1 equals 13 from right here, and B2 equals 25. So let's start plugging those in and see what we get. Let's see, we're going to have 1/2 height, which was 8, times the quantity. B1 is 13 plus B2, which is 25. And then we can attack it. We have some parentheses. That's what we have to deal with first. So we'll just carry everything else down. 1/2 times 8. Put a little multiplication up there to make it clear. And that is the quantity. 13 plus 25 is going to give us 35. 8. And now, because we just have a single value within these parentheses, we can get rid of them as long as we know what was happening to them as we multiplied. So now we're just left with 1/2 times 8 times 38. For me, it's going to be easier to multiply the 8 by the 1/2 first. So let's do that first. We'll bring everything over here. 1/2 times 8 is 4 times 38. Now my multiplication tables aren't that good, so let's do this longhand. 38 times 4, so let's see, 8 times 4 is going to be 32. And 4 times 3 is 12, plus 3, so 12, 13, 14, 15. 152, and that is our answer. Or is it? We're dealing with area here, so we always want to make sure that we're notating what this 152 is. So we're going to look for 152 meters squared. Because we're dealing with area, it's not just meters, because that would give us a length. We're looking for area, so meters squared. And that is Chapter 1, Section 1 notes for Algebra 2. Again, this is just a review, so this should all sound fairly familiar to you, but if it's not, please talk to your teacher. We're going to give you extra insight into this and continue to go through Algebra 1 notes. So if you have questions, ask away.